Welcome again to A-Star Science and our GCSE Must Know Chemistry series. Today we're going to look at acids versus bases, another important topic, something that always comes up on the exams. So let's first look at what acids are versus bases. What are their properties? So we can do a quick little table. If we put acids on one side and we put bases on another. Acids tend to taste sour, whereas bases taste bitter. Of course, in the classroom, we're not going to go around tasting any acids or bases, but we know that, for example, lemon juice, which is a well-known acid, tastes quite sour, whereas bases, something like, for example, you may have had happen to you, something like soap that ever gets into your mouth, you'll know that it tastes quite bitter. Okay, so acids taste sour, bases taste bitter. Acids contain, at GCSE level, you need to know that they contain the H plus ion. Okay, it's H plus ion. An ion is a charged particle, whereas bases contain OH minus, or the hydroxide ion. Okay, so those are two differences. We know, of course, from our key stage 3 that the pH of acids is 0 to 6, whereas the pH of bases is 8 to 14. Okay, and some common acids, for example, as we know, hydrochloric acid, HCl, and some common bases are things like sodium hydroxide. We know it's a base because, as we said, it contains the OH minus ion, whereas the acids over here contains the H plus ion. Very important, the difference between acids and bases. So now let's take a quick look at what a strong acid is versus a weak acid. So first of all, a strong acid is an acid that fully ionizes. Fully ionizes. Well, what does that mean? Well, we can look at HCl for an example. Hydrochloric acid is a strong acid found, for example, in our stomach. Our stomach acid has hydrochloric acid. When we show it ionizing, we put a one-way arrow, meaning it's irreversible. That reaction is going to go one way. It's irreversible. And that's going to ionize into the H plus ion plus the Cl minus. Hydrogen is associated with group 1, so it will lose one electron and become H plus, and the chlorine will gain one electron and become 1 minus. And so when that hydrochloric acid ionizes it becomes H plus Cl minus. We know it's a strong acid because of that one directional arrow. Weak acids, they partially ionize. So for example, water is a weak acid. Water can act as both an acid or base. But if we look at water as a weak acid, we're going to draw a reversible arrow like that. So that's going to go two ways, and that's going to ionize into H plus OH minus. So we can see on the right-hand side, 2 hydrogens, 1 oxygen. So we know it comes from the water, which has 2 hydrogens and 1 oxygen. But look at the arrow. It's a two-way reversible arrow. The reaction's reversible. And because it's reversible, we say it partially ionizes. And that lets us know it's a weak acid. In other words, it can go backwards and forwards as a weak acid. So some examples of strong acid, as we said, are things like HCl, hydrochloric acid. Sulfuric acid is another strong acid. Even phosphoric acid, H3PO4, is a strong acid. Some weak acids are some common weak acids we even know about. Citric acid, which we find in citrus fruits, okay? And even vinegar, which we call ethanoic acid, is a weak acid. And we'll talk more about that in another video. So those are the differences between a strong acid and a weak acid. Let's quickly look at bases. We can draw a line. So bases, as we said, contain the OH minus, okay? They contain the OH minus ion, for example, sodium hydroxide. Now, you often hear this word alkali. An alkali is a base, but it's a soluble base. Alkalis are soluble bases. For example, we know soap dissolves in water, right? It's soluble, okay? Not all bases are soluble. Soluble bases tend to be the ones that have OH minus in them, like the sodium hydroxide. Whereas insoluble bases, they, for example, are metal oxides, which are insoluble. So, for example, copper oxide would be an insoluble base. It will react with an acid, but it is insoluble in water, as well as our metal carbonates. They are also insoluble. So a good one to think about would be calcium carbonate, which is limestone. And we know that limestone, as a rock, if you put it in water, it's not going to dissolve. So that's the difference between bases and alkalis. Bases can be soluble, which we call alkalis, or they can be insoluble, which we call metal oxides and metal carbonates. They act as insoluble bases. So as a quick summary, let's go back up to what we were looking at. Our topic was acids versus bases. Acids taste sour, whereas bases taste bitter. Acids, very importantly, contain the H plus ion. Bases have the OH minus or hydroxide ion. The acids, the pH is 0 to 6, whereas bases is 8 to 14. An example of an acid is hydrochloric acid. An example of a base is sodium hydroxide. Strong acids, they fully ionize, whereas weak acids, they partially ionize. And then we have bases. Not all bases are alkali, but all alkalis are bases. So for example, bases contain the hydroxide, the OH minus, and they are soluble bases, whereas insoluble bases are things like the metal oxides and the metal carbonates.